Math 2, lesson 5.2. Okay. Yesterday we talked about polygons, so we talked about all different shapes, right? However many sided figure would depend on how many degrees it has and all that kind of stuff. Today we're specifically going to talk about parallelograms. Okay? Before we get into today's lesson, at the top of page 270, you do not have these questions, but I want you to find the answers to these questions. So I want to make sure you remember how to do this, okay? So I'm going to give out candy to the first 3 people that get all 3 of these answers correct. So once you get the answers to those 3 questions, raise your hand and I will come check them. And you can just write these at the top of page 270 in that blank spot. Okay. You don't have to write the question, I just want the answers.
I got number 1.
You need all 3. All 3 answers. You might want to go back and look at your previous notes. All 3 answers. Okay, 1, 2, 3. Okay.
No, I have it.
Okay, I know, but it's 3 hands. Okay, I'm gonna check you can be one of mine. Okay. Okay. No.
I did 18 minus 2.
Yes.
20 divided by 16.
That's sorry. That's correct. Second answer?
Divided by 2. That one you don't divide by It's not regular. It's not regular. The one you do.
Correct. The first person. Ready to go. Hey, Diana, I'll be to you. It's correct. All right. Okay, so a lot of you are struggling with some of these, so let's check it out. Okay, I'm talking, you're not. Now it's your turn to be quiet. Shh. Interior angles. That is when we go n minus 2 times 180. 18 minus 2 times 180. 16 times 180 equals 2,880. Okay. Now, pentagon has how many sides? 5. 5 minus 2 times 180. 3 times... Okay, I already gave out my candy. 3 times 180, we're going through this now, is 540. Now, that's how much all of the interior angles add to be. We have to add these together and subtract it from 540. So you should have 540 minus 442, which is 98. Okay. This one says exterior angle. What is the sum of all exterior angles? 360. And this is a 20gon, so we divide by 20 in order to evenly disperse it. Zeros cancel. 36 divided by 2 is 18. Those are the 3 answers you should have got. Do we have questions about any of those? Okay. What? No. All right. Staying on page 270. Okay. I'm getting ready to make a new seating chart, so please stop talking when I'm talking. Okay, we have a parallelogram. Okay? If a quadrilateral is a parallelogram, then its opposite sides are congruent. What does congruent mean? Equal. Okay, now it's not saying all sides are equal, it's saying opposite sides are equal. Okay, we know that they're parallel when we see these arrows, right? So 2 arrows means BC is parallel to AD, and over here it has 1 arrow, and we know AB is parallel to CD. Okay, we know that parallel, when we're writing it, we do the 2 lines up and down. That means parallel. Okay? Okay. So what they're saying is if you have a parallelogram, if you have 2 sides, opposite sides are parallel, then that means that the opposite sides are congruent. So BC is congruent to AD, and AB is congruent to CD. Not that all 4 are equal to each other, but that opposite sides are congruent. Are we okay with that? All right, let's look at this proof here on page 271. They have it all written out for you. Okay, so we're on 271 now. So they said, given this parallelogram, and you'll notice that they drew, this is called a transversal, okay, or connecting, it's a diagonal, okay, through there. And so they want us to prove that AB is congruent to CD and that BC is congruent to DA. So first of all, given is that it's a parallelogram, okay? Step 2, if it's a parallelogram, we know that 2 sides are parallel. So they put AB is parallel to CD and BC is parallel to DA, and that is by a definition of a parallelogram. It has 2 sides that are parallel, okay? Based on that, if you have this line going through here, since these are both parallel, that means that angle 1 and angle 4, so this angle right here, angle 1 and 4, and then angle 2 and angle 3, that they are alternate interior angles. So again, if the lines are parallel, then you have alternate interior angles. Now, does it mean that angle 1 and angle 2 are equal? No, it just means that 2 is congruent to 3 and 1 is congruent to 4. We know that AC right here is congruent to AC by reflexive property. So that means that this line right here, that's congruent to itself, right? And so these 2 triangles right here are congruent by angle, side, angle. So remember, you're only reading it with one of the triangles, and we always go in order. And either way I go, it's still angle, side, angle. Okay, right, Fernando? Okay, and then the last thing is that we're trying to prove this. We weren't trying to prove the triangles, we are trying to prove something specific. And so the last thing is your CPCTC, which is congruent parts of congruent triangles are congruent. Okay? This will be something you want to look back at and might see on your test. Okay. Yes. Always. Maybe not at the end of the year, but for a while. First semester, there's lots of proofs. Okay. Page 271, still. Okay, on Theorem 41. It is talking about consecutive angles. Okay? Consecutive angles are on the same side. So they're saying right here, B and C are consecutive angles. C and D, consecutive angles. D and A, consecutive angles. A and B, consecutive angles. Okay? Another thing to know is that consecutive angles, and this is right down here, they are supplementary. What does supplementary mean? 180 degrees. So that means on any side of a parallelogram, those two angles will add to be 180 degrees. This is a super important concept to know. So there are a lot of different ways I can add up in order to equal 180, and a lot of people mess up on this. So just know that the same side, those two add to be 180. So B and C, C and D, A and D, A and B. All of them add to be 180. So that brings us to some problems. Let's turn to page 272. How would I set up the equation for number 1? To solve for x. Are these consecutive angles? Yes. Are those two on the same side? Yes. So we could write this as 53 plus x equals 180 degrees. What would I do to solve that? These cancel. X equals, I have to borrow, or you can use your calculator. And we get, oh my goodness, if I can actually subtract, 127. Okay, number 2. How will I set up that equation? Same thing, 113 plus x equals 180. Seth, are you getting this? Okay, so we subtract 113 from both sides. These cancel. And x equals, we have to borrow. And we get 67. Okay, do we have any questions? Pretty easy? Okay, so do we understand it can be any two angles as long as they are both on the same side? Those add to be 180. Okay, still on page 272, I want to look at Theorem 42 and 43. Okay, so on 42 it says, if a quadrilateral is a parallelogram, then opposite angles are congruent. So the whole angle, so A is congruent to C, and B is congruent to D. Okay? So that means, and we still know that all of them equal 180, right? If you add two sides together, they equal 180. A and C don't add to be 180. Those are congruent. Those are equal. Okay? And then on Theorem 43, if you were to take diagonals and cross them through, notice, are they saying anything about the angles of A and C in this figure? No. They are talking about the diagonals. If you have two diagonals going through there, okay, they end up bisecting each other. And what happens is that if you notice here, A to E is congruent to E to C. So these two pieces are equal to each other. And then same on the other side. BE is congruent to ED. Now, is it saying that both of those are equal to each other? No, the two lines are not necessarily equal to each other, but we know that it bisects it, so each of the halves are equal on the same line. Okay, so now we're going to take out our yellow card. Okay? We're going to start on the side that has all the shapes. So if you notice here in the middle, it says parallelogram. That is what we're talking about today. I want us to list all the things that we know to be true about a parallelogram. It does have something to do with parallel. So what is it? What makes it a parallelogram? Okay, so I like that. So first thing is I'm going to write a quadrilateral. So I'm just going to put quadrilateral with, and when we abbreviate with, we do a W with a line. You guys know that? Okay. With both pairs of opposite sides parallel. And remember, parallel is those two lines up and down like that. Okay, so that is one thing we know about a parallelogram. And you might need to go back and look at page 271 and 272. But tell me something else that we know about parallelograms. Very good. So I'm going to write that as consecutive angles if I can spell. Okay, consecutive angles are supplementary. And again, what does supplementary mean? Very good. So I'm going to write that there just so I can remember. Okay, tell me something else we know true about parallelograms. Say that again. Okay, it has four sides. Good. Okay, we already kind of stated that with the quadrilateral. Okay. Okay, I think that what you're saying is that opposite angles are congruent. And do we understand that that means congruent when you have the equal sign with the little squiggly on top? Okay. Okay, what else? Just on like, okay, Fernando, go back to your seat, please. What else do we know? Just like on the last two theorems that we talked about. Something about the diagonals. What happens with the diagonals? Not congruent. They bisect each other. Very good. Diagonals bisect each other. Okay. And there's one last thing, and I think it goes back to page 271 or maybe even 270, but it has to do with the opposite sides. So we talked about how opposite angles are congruent, but also opposite sides are congruent as well. Okay, are we good? As you finish writing those things down, these are what we know to be true, okay? Those things. So when you flip it over, we are gonna mark what we know about parallelograms to be true on the opposite side. So hopefully you're using a pencil. I'd like you to just to make little marks on which ones you think are true, and then we'll go through it and really mark them for which ones we know are correct. Okay, so we'll see if you can get it correct. Does everybody have this written down? Can I flip it or wait? Wait? Okay. So you're going to try to mark what you think on the opposite side in the boxes. Okay? Which ones you know are for sure true. Oh, you need me to go back? Okay. So, do you guys need another minute? So I kind of just read through them and decide is it true or false in order to mark it. Okay. Does it have two pairs of opposite sides parallel?
Yeah.
Yes. So we can put a big X in that one now. We know that one is true. Does it have exactly one pair of parallel sides? No. We already said it has two, right? Okay. Does it have two pairs of opposite sides congruent? Yes, that is true. Has two pairs of consecutive congruent sides, but opposite sides are not congruent. Is that true?
No.
No, that is false. Are all sides congruent? Do all sides have the same value? No. Are the diagonals congruent?
Yes.
No. Okay? We talked about how the diagonals bisect each other, but we never said they're congruent. Remember how we did one slash mark on one of the sides and two on the other?
Yes.
We don't know that the actual diagonals are congruent. Are the diagonals perpendicular? Did they make 90-degree angles?
Yes. No.
It never said anything like that, so that's false. Did it ever say anything about it bisecting the angles? No. It talked about it bisecting the diagonals, but it didn't say it bisected the angles. Do the diagonals form two congruent triangles? Yes, and we proved that. Remember how we went through that proof, the angle side angle? So yes, the diagonals form two congruent triangles. Okay. Do the diagonals bisect each other?
No. Oh, yes.
Yes. We just talked about that. Yes, the diagonals bisect each other. Are opposite angles are congruent? Yes, we did talk about that. Are all angles right angles? No. Consecutive interior angles are supplementary?
Yes.
Yes. So that's where we said any two angles on the same side are supplementary. How many of you got them all correct? How many of you only missed like one? Good. Okay, do we have questions on any of these or any of them that don't make sense? Are we all good? Okay, going back to our notes then. Please turn to page 274. Okay. Fernando, did I need to put you all by yourself? Yeah. Okay. All right. Find the value of x and y in this parallelogram at the right, and then it asks you what is PR and what is SQ. What did we learn about the diagonals? The diagonals do what? They bisect. So that means that these two sides can be set equal to each other. So I would write this as 3y minus 7 equals 2x. My other equation would be what? X plus 1 equals y. Now, how could I solve this? Very good, substitution. Since this has y by itself, I'm going to plug in x plus 1 for y. And right here, do we see how we have a 3y? That means there's 3 x plus 1s, right? Well, the shortcut is we just write this as 3 times, and whatever y is, we plug that in, x plus 1, minus 7 equals 2x. And what would I end up doing? Distributing. So let's distribute and solve. I'll come back in a second. Okay, so 3x plus 3 minus 7 equals 2x. Okay, combine our like terms. Okay, so we get 3x and 3 and negative 7 makes negative 4 equals 2x. Then I'm going to subtract 3x to get all my x's together. These cancel. Negative 4 equals negative x. So that means positive x would be positive 4. Okay, so I found x, and then now what do I do? I'm going to substitute that in right there for x so that I can find y. Okay, so that means I have 4 plus 1 equals y. 5 equals y. Does anybody have questions on any of that? Okay, but remember, whenever we solve for x and y, we want to go back and see what did the question actually ask. Did they ask for x and y, or did they ask for something else? What did they ask for? Okay, so if we go to PR, the easiest one to plug in is for x. So what is 2 times x? 2 times 4, which is, so if this is 8, then that means this side is also 8 without even plugging it in, because we know that they're equal. And so that means that PR equals plus 8, which is, because it wanted the whole length. Okay? Then, for SQ, so here is the SQ line, right here. Do we agree? Okay. On one side of the line, it just has the value y. So that means this side is 5. Without even plugging in x. But if I wanted to, 4 plus 1 gives me 5. But once you know one side, you know the other is the same value. So that means that SQ is 5 plus 5, which makes 10. Do we have any questions there? Okay. The reasoning. In problem 3, does it matter which variable you solve for first? Does it matter if I solve for x or y first? No. Let's just put no. Order does not matter. You could find x before y or y before x. Okay, any questions here before we move on? Okay, still on page 274. So over here you have this figure, okay? It's telling you it's a parallelogram. So that means that PT, this side, is equal to TR. So my equation, how would I write that? Good, 2x equals y plus 4. What's my other equation going to be? Very good. X plus 2 equals y. What will I do in order to solve? Substitute. Since this is y equals, we're just going to take this and plug it in for y. Are we writing this down? Okay, so we have 2x equals x plus 2 plus 4. Because instead of y, we're writing x plus 2. We combine our like terms. I have 2x equals x plus 6. And in order to solve for x next, I would subtract x. So that means that x equals 6. How do I find y? Good. So that means I have 6 plus 2 equals y. So that means 8 equals y. Go back and check what the question asked. What did they ask us to find? X and y, right? So am I done? Yes. Good. Okay, this next one I was going to have you try on your own, but for time's sake, we are going to do this one together. So how will I end up setting up this equation? What would be my first equation? Good, x plus 2 equals y. And the next one? 2x equals y plus 3. Do you think you guys would be okay to solve this one? Okay, I'm going to let you go through it real quick on your own. And when you get the answer for x, you can show me on your hand what the answer is. Good, 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 good. Good, good, good. 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 Good, good. Okay, so the correct answer is 5. So I take this, I substitute it in. 2x equals x plus 2 plus 3. 2x equals x plus 5. Subtract x to both sides. X equals 5. To find y, I just plug it in here. And so I'd have 5 plus 2 equals y, so 7 equals y. And that is my answer. All right, turn to page 275. Okay. This is another important theorem. Okay. So notice it tells you that each of these lines, A, B, C, D, E, F, they're all parallel. Okay? If they go through and if they tell you, and if you look right here, do you see how they're saying CE is congruent to CE, or sorry, CE is congruent to AC? If that is true, then that means on the opposite side, those also have to be congruent. Okay? So if they tell you that one pair over here, if these are congruent, then over here, these also have to be congruent. Okay, so we're going to put this into effect and check these questions down here. So if you notice on this one, they told us, first of all, we know that all of these lines are parallel because they have the little arrows in them. And then it says EF, FG, and GH all equal 6. So since all of these are equal, that means on the opposite side, each of these pieces here also have to be equal. Now they told you that the whole thing is 15. How could you figure out how much each piece is? What would you need to do? Yeah, so how many pieces are here from A to D? There's 1, 2, 3, correct? So we would say 3x equals 15. Divide by 3 to both sides, so that means each portion equals 5. Okay, so do you guys see how from A to B, B to C, C to D, there's 3 pieces? So we're evenly dividing it by 3. You could have just taken 15 divided by 3 to get 5 as well. Okay? All right, on this next one. Again, they are telling you here that PQ is equal to QR is equal to RS. Okay, that means that if those are all equal, everything else is equal. Okay, including diagonals. So when they're asking for ZU, okay, they're asking from Z to U. Do you see here how they're saying this is 3? Then that means this piece is 3 and also this piece here is 3. So ZU equals 3. On WV, they want this whole thing here. So if we know one of them is 2.5, then this one's also going to be, and this one's 2.5. And so you could add 2.5 3 times, or we could go 2.25 times 3. And when you do that, you should get 6.75. Okay. We are going to go ahead and stop there. We're not going to do any of the lesson checks today, but on what we've learned, does anybody have any questions?